Hi everyone, it's Miss Craig again. We're now on to lesson 2 for the week of May 4th through the 8th. We're doing the learn about it for dilations and similarities in the coordinate plane. So first we're going to review the transformations we had already done earlier this year. They're rigid transformations because they are, once they're moved, we're not like expanding them. So first we had the reflection. So the reflection, we go across the line and they're the same distance. It's kind of like you're flipping that pancake. So a rotation goes around a point. So that's when we're kind of twisting it. And then a translation, we are going to move in the same distance. So that's kind of like a slide. So we have the flip, the turn, and the slide. What we're now going to focus on is something called a dilation. So it's multiplying its dimensions by a factor. So we are going to either stretch it out or we're going to put it back together. So it's kind of like if you think, we do this a lot of times on our phones. So we have a picture, we want it bigger. We then kind of move it out to make it bigger, and we can make it bigger again, or we could shrink it back down. So with dilation, we're talking about either blowing something up or shrinking it back down again. So if we are taking the original ABC, so here's our original ABC, and we are going to dilate it to A prime, B prime, C prime. So remember, a lot of times when we are thinking, or when we're making our new figure, we use those little things, they're called prime. That shows us what our new image is. So again, we changed the size and the location, but it did not rotate or reflex. It's kind of like we took this one. It's kind of, imagine with your fingers, you're blowing it up, and we get the A prime, B prime, and C prime. Example 1. So we have our quadrilateral A, B, C, and D, and we want to make our new one using a factor of 3. So for factor 3, again, tells us what we're multiplying by. The big thing is you want to make sure that you are multiplying both the x value and the y value so that it stays in proportion. We want to imagine that we are multiplying both by 3. So if we multiply both by 3, A prime would then be 9. 3 times 2 is 6, would then be 9, 6. We plot over 9 up 6, 9 up 6, and that would be our A prime. This was our A, B, our C, and our D. So same thing to do B, we're going to multiply everything by 3. So B prime would be -3, 6. So we would have -3 up 6, and be our B prime. So again, to get C prime, we multiply both coordinates by 3. So C prime would be -6, -6. So left 6, down 6, here, C prime. And then again, to get D, we multiply everything by 3. So it'd be 3, -6 over 3, down 6. That would give us C prime. And then if we connect, that gives us our new quadrilateral. So kind of some important things to note is if we imagine from point E to A and then A to A prime. We can see it's kind of broken into 3 equal sections, and that tells us that it's a factor of 3. So same thing if we look the other way, if we're going from E to C and then C prime, we can then see that we have a total of, again, 3 equal sections. That's how we know it's a factor of 3. And then same thing if we look at E to D and then D prime, again, we could think of that we have, again, it breaks it into 3 sections. That tells us we have that factor of 3. So if we're talking about from the origin and we want to find our dilation. So again, on this one, we have our shape. So we have A, B, C, D, and E. So this time we are doing a factor of 1/2. So that means everything we are multiplying by 1/2, or we think we're cutting it in half. So if we're doing by 1/2, we could think we are multiplying by 1/2. So A prime would give us half of -4 is -2. Half of -2 is -1. So we would have -2, -1. So now we want to think, is this making sense? So if you're cutting something in half, are we getting bigger or smaller? We can see that we are getting smaller. So now again, we're going to multiply everything by 1/2. So 6 times 1/2 is 3. -2 times 1/2 is -1. So we would have 3, -1. That'll give us our A prime, our B prime. So keep going by 1/2. So 6 times 1/2 is 3. 4 times 1/2 is 2. Gives us our C prime. Again, by 1/2, D prime would be 0, 3. D prime. And then our E times 1/2 times 1/2. So that would give us 0, 2. That would give us our E prime. And if we connect our points, you can see it's the same shape, it's just at different sides. It's been shrunk. So now if we want to find the scale factor, so we have both of the points, but we want to know what is that scale factor. And again, it tells us from point D. We're going to set it up as a proportion. So if we go from, want to know, how do we go from D to B prime compared to how do we go from D to B? So D to B prime, if we look, D up to B prime is 1, 2, 3, 4 units. D to B is up 1 unit. So we'd have a scale factor of 4. So again, to find that scale factor, we just set it up as a proportion. How do you go from the point to the new image over that same point to the original image? So just for a couple of things. So if our enlargement means that we are getting larger, so we're going to multiply by a number greater than 1. A reduction means that we are getting smaller. So we multiply between 0 and 1. When we are going about the origin, we multiply each coordinate by the scale factor. And if we are talking about compared to a point, we compare the proportional between the image and the pre-image. So you would have the new divided by the original, or distance to the new divided by the original. So you'll watch any other videos on this, learn about it. You'll go to the try it section, watch any videos, do all the practice, check your answers. If you have me and Miss Thomas, then you'll do the additional activity. Take care of yourselves, and we'll talk soon.